Oblique triangles. First thing we're going to talk about is the law of cosines. This is given to you on your formula sheet as well. So you use the law of cosines when you are given side, 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 or side, angle, side. Those are the only two times you can really use this to solve for any angle or side. Okay. In this first example here, find x to the nearest tenth. We're given the three sides and we have to find that angle. The key to this is this loneliest side here. I don't really care what letter it is. I just want it to be opposite from the angle that I'm going to be using for the cosine. So in this case, the loneliest side is 8. 8 squared equals 10 squared plus 15 squared minus 2 times 10 times 15 times the cosine of x. Okay, so that is going to give me minus 300 cosine x. 10 squared is 100. 15 squared is 225. And this guy is 64 here. Okay, now a common mistake here will be to combine all of this, 100, 225, and 300. But that 300 is not a like term, so it's 325 minus 300 cosine x. And that equals 64. What I have to do is just subtract the 325 from both sides, okay? Don't make that like 25 and then try and solve from there, okay? So when you subtract that, 64 minus 325, 64 minus 325 is negative 261. Okay, so I have negative 261 equals negative 300 cosine x. And what I'm going to do is divide both sides by negative 300. So it's going to give me 261 over 300. Because when I divide a negative by a negative, I get a positive. And then I take the arc cosine of that and I'll find my x. So it is second cosine 261 divided by 300. Enter. And it says to the nearest tenth, so that is 29.5. So x equals 29.5 degrees. Okay, that's the first application. Now in another case where I am given side, angle, side here. And you can see that because I know this side, and I know this angle. So it's side, angle, side here that I'm given. The key to law of cosines is identifying what I call the loneliest side, right? That's the side across from the angle that you're going to use. So in this case, x squared. X is the loneliest side. So 10 squared plus 11 squared minus 2 times 10 times 11 times the cosine of 100 degrees. Okay, and this can all be put in your calculator kind of all in one fell swoop here. So I can do like 10 squared plus 11 squared minus 2 times 10 times 11 times the cosine of 100. Okay? And they get that value. Okay, I'll stop right there for a second. X squared equals 259.2025991. And then to solve this, I take the square root of both sides. All right, and then without doing anything to this, I just hit second x squared to get the square root, and then I'll do second negative sign for the answer from the previous computation, and I get 16.0997. So that's going to be to the nearest tenth here, 16.1. Okay, that's how you kind of use the law of cosines. All right. Another way to solve for an angle or a side in an oblique triangle is the law of sines. All right. And this kind of looks goofy. Remember, you're only going to use like 2 of them at a time. Like maybe I'll do these 2, right? Or maybe it's going to be B and C that I'm going to be using. Maybe I'll just be concentrating on this 2, right? And so you don't use all 3 at once. All right. That's just the way they present the formula on the reference sheet. Use the law of sines when you are given, okay, and you can use this when you have an angle side or an angle side angle, all right? And some cases, all right, you can do it when you have angle side side, okay? That last one there is special. That's called the ambiguous case, right? The ambiguous case. And it's ambiguous because there could be 0, 1, or 2 triangles possible with that. Okay, so first one here. Looks like I have a side, angle, side. Angle, side, angle. Angle, side, angle, right? So that's going to be a law of sines. All right. In order to do this, I need 4 over, I also need an x. Why don't you just go ahead and mark this side x? It doesn't matter. It could be either one of those. And it's going to depend how I'm going to write my equation. 4 over the sine of, I don't know that angle, equals x over the sine of 35, right? Well, to find the angle, you know the three angles in a triangle have to add up to 180. So that leaves me like 40 plus 35 is 75. So that's going to be like 105 there. Okay? And then I'm going to kind of cross multiply here. So it's 4 sine 35 equals x sine 105. And then divide both sides by sine 105. All right? You didn't have to multiply both sides by sine 105, but we're kind of used to using solving proportions by cross multiplying, so I just kind of go with it. 4 times sine 35, and then I can hit enter, and then divide that answer by the sine of 105. Okay? And that will give me my x. X equals, it doesn't say it to a place in these directions, so I will do the nearest tenth. Okay? As long as you round appropriately, if it doesn't give you a place, then you can round to the nearest tenth. Don't round that to a whole number, please, okay? Because it's a lot more accurate than that, okay? If you say, oh, that's 2, that's really kind of approximating too much. All right, so how many triangles are possible? And this is where this ambiguous case is always used, right? See how I have the side angle? When they're asking me this kind of question, I'm going to kind of I'm going to add some stuff here. I'm going to label this angle A, this angle B, and this angle C, all right? And what I like to do is I like to kind of do this chart, remember? And there's going to be maybe 2 possibilities here. Now, this angle A is always going to be 40 degrees. It was given, that doesn't change, all right? But now I can use, like, the law of sines and find angle C here, okay? And that would happen with 10 over sine 40 equals 8 over the sine of C. 10 over the sine of 40 equals 8 over the sine of C. Yeah, okay. Yeah, there we go. So I'm going to find this by cross multiplying 10 sine C equals 8 sine 40. So the sine of C is going to be 8 sine 40 divided by 10, okay? So I can do the arc sine of that. So second sine, all right? And now I want to do parenthesis 8 sine 40, close that guy's parenthesis, close the parenthesis for the numerator, divided by 10, close the parenthesis for the arc sine, okay? And that will give me my reference angle. That's really kind of alpha here, right? Well, that's one possibility for C. And we can round this to the nearest degree, okay? So we'll say that's 31 degrees. So I know C is 31 degrees. Now what I want to verify is there enough left over for me to have, can I get an angle B that will add up to 180? And I can, 109. If you add all those together, that gives you 180. So I know there's at least one triangle. The times I'll have 0 triangles is when I do this first part here, right? And it just doesn't work, all right? Because it'll give you something greater than 1 or, it'll give you something greater than 1, all right? The other possibility is because sine is positive in the first 2 quadrants, alpha was 31, so the first answer for C was 31. The other C is 180 minus 31. So I take 180 minus 31, right? And that's going to give me 149. So conceivably, that could be 149. Here's the problem with this. What's 149 plus 40? That's 189. We've got nothing for the B. That's just not possible. So how many triangles could I make? 1 triangle, okay? If the sum of A and C had come out to be less than 180, then I could have had a second triangle, okay, using the second quadrant answer. Okay, moving on. Area of a triangle. And this K equals 1/2 AB sine C is on your formula sheet. This one is on the reference sheet. This one isn't. Okay, you just have to remember the parallelogram is basically 2 triangles put together. So instead of being half AB sine C, it is just AB sine C. And the letters don't matter. Use any two sides, and the angle between them. All right? So you can see here I've got 8, 12, and 20 degrees, and they want me to find the area. So K is going to equal 1/2 8 times 12 times the sine of 20. Right, and then I can just put that on my calculator. I can use 0.5 for a half, and it'll be a really quick, easy computation. Or I can do half of 8 in my head, right? 4 times 12 times the sine of 20. All right, and that'll give me the area. Now again, it doesn't say that what place to round it to. It usually will. I just kind of forget to put those in the questions a lot. Okay, so in this case, I got k equals 16.4. Again, I rounded to the nearest tenth if I wasn't specified to. All right, find the area of the parallelogram. All right, now this one here, I've got 10 and 15, and it doesn't look like I have this angle between them. But with a parallelogram, what you have to keep in mind is, well, two things. Consecutive angles are supplementary, so I could figure out what this angle is. And also with parallelograms, the opposite sides are congruent. So really, I do have two sides and the angle between them. So I could just do that. All right, so k equals 10 times 15 times the sine of 95. All right, and 10 times 15 times the sine of 95. All right, just make sure your calculator's in degrees and you won't really have any problems here. So the k is 149.4. Okay, so that's how I can do an area problem. Those ones are pretty simple, I think. All right, multiple triangles. Listen, the key to this is always going to be the shared side. When you have these multiple triangles, there's going to be a side that like applies to both triangles. So if I'm talking about like this blue triangle as one of my triangles, and I'm talking about this red triangle as my other triangle, there's my multiple triangles, and you can see they're sharing a side. This side right here, we'll call that y. I want to find him first, okay? So if I want to find him, listen, I know 10 on the blue triangle, I know angle 20, and that's kind of all I know. If I go on, I can figure out what these other angles are. If this is a 180-degree angle straight across here, then this is 140, and if this is 140 and this is 20, that makes this guy, ooh, not drawing a scale, I guess. That makes this guy, that's pretty close, I guess. That's 20 degrees as well, okay, because the sum of the three angles is 180. So I have 10 over the sine of 20. 10 over the sine of 20 equals y over the sine of 20. All right, well, now since this is isosceles, it's kind of obvious here that y is going to be 10. So I got a little shortcut there. I got lucky, I guess. All right, so from there, and then you could solve that just like we did the other law of sines problem also. Okay, so y equals 10. Now, once you know y equals 10, now I'm going to focus on the red triangle. Oop, I could have used red. Sorry about that. I'm focusing on the red triangle, where I know this is 40 degrees, and I know this is 10, and that's a 90-degree angle. Now, since that's a 90-degree angle, I can use right triangle trig and figure it out pretty easily, right? Because it's the opposite over the hypotenuse. The sine of 40 equals x over 10. What you can do is you can figure out this other angle here, right? Or you can use the law of sines. I can do 10 over the sine of 90 equals x over the sine of 40, all right? And that'll give me the answer as well. I'm going to use this right triangle trig here and do 10 times the sine of 40, and that will give me my x. So my x is 6.4. If it's said to the nearest tenth, it doesn't. So no directions yet again. Okay, the last one here that I have for the video is a force problem. All right, and these force problems are always going to make parallelograms. That's the key to this. Two forces of 35 and 40 act on an object. If the magnitude of the resultant force is 50 pounds, so I've got a 35-pound force here and a 40-pound force here. Oops, 40 pounds there. All right, and I'm telling you that the resultant, the magnitude of the resultant, that's like where does the object actually move, and I tell you that that is 50. All right, I'm going to get this force parallelogram here. All right, and 50 is the resultant. It wants me to find the angle between these two forces. And the problem is I can't find that angle directly. What I'm going to do is you find this angle first. Since the opposite sides here and here are congruent, now I can kind of focus on one triangle here. 40, 50, and 35, and I'll call this x, and then I can use the law of cosines to find x. Once I find my x, then it's going to be 180 minus x for my answer. Running short on time, so that's as far as I'm going to get. Thanks.